All right, so somebody first period asked me why we were going back to 6th grade work. Yes, area and perimeter are things that you learned in junior high, but we are going to extend this and use geometric rules in order to find length and width. You're not going to just be given length and width on every problem. You're going to have to use what you've learned so far in geometry to find length and width. But basics of area and perimeter have not changed. So how do you find area? It is the number of square units in the interior of a figure. So if we sketch that, I'm going to have you sketch it, but then I'm also going to have you show me the units. So we're going to do a 3 by 5 rectangle where I have 3 cubes that way, 5 cubes that way. That is demonstrating an area of 15 units squared. And then to find distance around that same figure, so if I draw that same figure, perimeter is just the distance around the figure, right? And so we just add 3 plus 5 plus 3 plus 5, and that gives us the perimeter. There are formulas for perimeter and area. This is the same formula you learned in junior high. Length times width gives you area. You may or may not have learned that you can, instead of just adding 4 numbers, you can do 2 times the length and 2 times the width and then add those together. So there is a formula for perimeter of a rectangle, and so there it lives. All right, and so we are going to review today, before we get into our perimeter and area, how to find missing sides of the 30, 60, 90 and the 45, 45, 90 triangle, because we're going to have to apply that to finding side lengths so that we can find perimeter and area. So this is a triangle, is a right triangle. It has a 60-degree angle here, so we know that one has to be 30. And so we remember our 30, 60, 90 rule. If you don't remember it, it is in your notes, but it's also up there on the board. The yellow triangle is the 45, 45, 90. The orange triangle is the 30, 60, 90, and so it has its ratios. So the ratio side lengths here, the shortest side we called X. The longer leg, does anybody remember?
X.
Square roots of 3. Very good. And then the hypotenuse was 2x. And then we're given that that side is 10. So when we solve these, this is how we wrote it. I wrote the ratio is equal to what's given, and then we solve that for x. If 10 is equal to 2x, then each x has to equal 5, right? So x is 5. That means this side here, because it's x, is 5, so BC is 5. And then AB is x square roots of 3, and we just said x was 5, so all I do there is plug 5 in, and so AB becomes 5 square roots of 3, and if we put that in our calculator, what does that approximate to? 8.66. All right, so we're reviewing this skill because we have to use this skill to find perimeter and area today. All right, this one is a 45, 45, 90, and that ratio, the legs were both x, and then 6 square roots of 2 is equal to x square roots of 2, because that hypotenuse there is x square roots of 2. So if I know that 6 square roots of 2 is the same as x square roots of 2, what must x equal? 6, the number that is in place of the x. And so that means each of these sides is 6, so DE is 6 and EF is 6. All right, this first example then is just straightforward reviewing you on what does it mean to find area and perimeter. So what is the length of this rectangle? I prefer to choose the longer side as the length and the shorter side as the width. It's a preference, but it doesn't matter. So 5 is the length, 4 is the width. So then how do I find that area? Multiply 5 times 4 and we get? So that's 20 square units. And then how do I find the perimeter? You can add all the sides. Is it just 9 plus 5? 5 plus 4 is 9? Are there just 2 sides? We have to remember there are 2, and that's why that formula comes in. It's 2 5s plus 2 4s. 2 5s is 10, 2 4s is 8, so the perimeter is 18 units. So that's just basic reminding you of perimeter and area. All right, but now if you look at the next example, we are not given a length or a width. We have to find the length and the width first. And so we know it's a rectangle, so that's 90. We're told this is 30, therefore this one has to be 60. So we have a 30, 60, 90 triangle. and we have the hypotenuse of that triangle is 4. So we go to our ratios. The short side is x, the longer leg is x square roots of 3, and the hypotenuse is 2x. So we know that 4 and 2x are equal, so x has to equal
2.
because we divide both sides by 2, and so x is 2. And so that means the short width is 2. And then what is the length? If I plug my 2 in, 2 square roots of 3, and if we approximate that with our calculator, 3.46. Thank you. Now I will say this, when you're calculating out area and perimeter, it is okay to just use this in the 2 square roots of 3 in your calculator. You will get a more accurate answer. If you round it and then use that rounded answer, you're not going to get as close to the correct answer. So for area, instead of using this approximation, we're going to use 2 square roots of 3. So to find area, it's length times width. So the length is 2 square roots of 3, and the width is 2. So in your calculator, type in 2 square roots of 3 times 2 and see what you get. 6.92. And now, did anybody do the 3.46 times 2? That is going to give you probably, in this case, the same answer, or very close to the same answer. But again, the rounding errors do get larger as the numbers get bigger. All right, and then how do we find perimeter? We add all the sides. So we have 2 of the 2 square roots of 3 plus 2 of the 2's. And we just did 2 times the square root of 3, and we got 6.92. And so we add to that 2 times 2, which is 4. So that answer should be 10.92. And then remember, the area is units squared, and the perimeter is just units. Somebody asked me, I think last period, is it okay for the perimeter to be larger than the area? Well, technically it's not larger. The numbers are larger, but this is linear units. This is square units. So yes, the numbers can be, the perimeter can look like it's larger than the area simply because it is linear units, not squared. All right. Area of a square has its own formula simply because squares are special because all the sides are the same. So instead of saying length times width, we can say side squared because really they don't have a length and the width, they just have a side. You don't have to do it this way. If you want to just do length times width for squares, I'm okay with that. But then the perimeter, this is extremely helpful. It is just 4 times one side, right? We don't really even have to add. We just multiply one side times 4. So this problem is interesting, and that I'm wondering if we're going to be ending up solving quadratics at some point, because what's going to happen here, our length and our width are both x minus 2, right? But now when I find the area, what is that going to look like? It's x, if I use the formula, it's x minus 2 squared. But what does x minus 2 squared mean? It means x minus 2 times x minus 2. Does this look familiar from algebra?
Yes.
All right, so what do I do now to simplify this? Well, we can't combine like terms because the like terms inside here, they aren't the same. And this means, and when I'm separating it with nothing in between, it means multiply. So do we remember that we have to multiply the x times the x? And what does x times x equal? Not 2x, but x squared. And then x times minus 2 is minus 2x. And then we do the same thing. We multiply this negative 2 times that x. Negative 2 times x again is negative 2x. And then this negative 2 times that negative 2. Negative 2 times negative 2 makes positive 4. Now I combine like terms. So x squared minus 2x makes minus 4x, and then plus 4. And so that becomes our area. We can't solve anything further because we don't have a value for x. And so x squared minus 4x plus 4 is the area of that square. And I'm going to be honest, I have not looked forward in this unit because I knew this unit is going to be interrupted so much by our benchmark week. Because for y'all it won't be, but for my morning classes it was. And I wasn't sure exactly how this week was going to look. And so I have not really looked forward. But this tells me we are probably likely going to be solving quadratics at some point. Do y'all remember how to solve quadratics? Do y'all remember that process?
No.
All right. I'll just keep that in mind. All right, and then to find perimeter, we just said it's 4 times the side length, right? So it's just x minus 2 times 4. And when I distribute that 4, what is that going to look like?
That's 5.
4 times x is 4x, and 4 times negative 2 is negative 8. So 4x minus 8 is our perimeter. All right, what if we have a square and the hypotenuse is 4 square roots of 2? And so we have a square, and we learned, I think the week that I wasn't here was this unit. When you cut a diagonal through a square, it cuts the 90-degree angle into 2 equal parts. So we know this is a 90, 45, 45 because it's a square cut by a diagonal. So we know this is 45, 45, 90, so we apply the x, and then the hypotenuse is what? X square roots of, on the 45 it's 2. So if 4 square roots of 2 is equal to x square roots of 2, what does x equal? 4. So the x is 4, so our length and our width are both 4. And so then how will we find our area? It's 4 squared, right? And what is 4 squared? 16. And how will we find our perimeter? Or multiply 4 times 1 side length, which would be 4 times 4, which by coincidence also here is 16. Number 7, a square with a diagonal of 6. So let's draw that. Let's draw a square. Draw its diagonal. It's a 6. And so because it's a square, I know this is a 90, 45, 45. And so my sides are both labeled with what variable? X. And then 6 is the same as x square roots of 2. And so now we have to solve that. X square roots of 2 is 6. So x square roots of 2 equals 6. So to solve there for x, divide by the square root of 2. So that cancels, and so x equals, if you put that in your calculator, what do you get? 4.24. And because we should not leave radicals in the denominator, I am going to encourage you to go ahead and just round that. So 4.24 is the length, and it is also then the width. So then how do we find area of a square? We just take that number and square it. And in your calculator, remember the squared key exists right here. So you can just 4.24 squared. A more accurate answer would be 6 divided by the square root of 2 squared, but I will take into consideration rounding situations. So what do we get there? 17.97. And I do believe if you put 6 square roots of 2 and then square that, you will get 18. And so that's what I mean when I say when we take the rounded number and then calculate with it, we get further and further away from the true answer. But I will take that into consideration as we work these. All right, and then perimeter. We multiply 4 times the side length. And what is 4 times 4.24? 16.96. All right, we are not going to do the example number 8. We're not going to do a problem like that, but there is something that's in our assignment that is not in our notes, so I'm going to add it. So on example 8, just cross out what it says there, and I'm going to give you a square, and I'm going to tell you that its area is equal to 36. So if the area of this square is 36, how do I find its length and its width? Say that again? So if the area is 36, how do I find area of a square? Side squared equals the area, right? So you take the square root of it. And so the side's going to equal 6. And so the side length here is 6, the side length here is 6. So then could I now find the perimeter? Yes, okay. All right, and then example number 9. So if it does not tell you a second angle measure, all we know here is this is a right triangle. We don't have a 30 or a 60 or a 45, so we cannot apply the 30, 60, 90 or the 45, 45, 90. So what other thing did we learn to solve for a missing side of a right triangle? Pythagorean theorem. So on this one, number 9, you would have to use Pythagorean theorem. And so we have a hypotenuse and a leg. So that's going to be squaring the hypotenuse and adding or subtracting the leg? Subtracting the leg. And that's going to equal the, let's call it the a squared. And so 10 squared is 100. 6 squared is, thank you, 36. And then 100 minus 36 is 64, and the square root of 64 is 8. And so the side length here is 8. If you remember that there are Pythagorean triples, the 3, 4, 5 triangle is a Pythagorean triple and any multiple of 3, 4, 5. So if you see that, you don't have to do this work. This was a Pythagorean triple because 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10. So the length here 8, the width 8. So then how do I find area? Length times width, 8 times 6. 8 times 6 is...
How is the length of the width?
It's not, you're right. It's not both 6. See, this is 6.
That's 6.
And that's 8. I'm so sorry. So length is 6, width is 8. Area is 6 times 8, or 8 times 6, which is 48. And now the perimeter,
48.
2 8s plus 2 6s is 28. Have y'all seen something like number 10?
Yes.
Okay, because other periods said they had not. So this is just called a composite figure. And do you see 2 rectangles? If you draw a line here, that is actually a rectangle and a square. So all you do here to find area and perimeter are find the area and perimeter of each, or excuse me, the area of each one, combine those areas for the area of the whole thing, and then to find perimeter, it's the same thing. You just go around the figure. So let's just start by finding the area of this square. So what's the area of a square that's 6 by 6? 36. And then I've got to find this length quickly. How do I do that?
5 plus 5 plus 6 plus 6.
5 plus 6 plus 5 makes 16. So now this rectangle is 4 by 16. And what's 4 times 16? 64. And so now the combined area is the area of that composite figure. So 64 plus 36 is 100. And then the thing that I find, the 2 errors I find with perimeter on these kinds of figures is you either forget a number altogether or you include sides that are not part of the perimeter. So this dotted line I drew in, its length is 6, but it is not part of the perimeter, right? And so this is an 8-sided figure. So 1, 2, 3, 4, 5, 6, 7, 8. So how many numbers should I be adding? 8. And so you can do this in various ways. If you want to combine your 6s and combine your 5s and combine your 4s, free to do that. Like however you want to combine these numbers with addition, do it that way. I'm just going to list them all out. So 16 plus 4 plus 5 plus 6 plus 6 plus 6 plus 5 plus 4, counting 1, 2, 3, 4, 5, 6, 7, 8 numbers. So I have all the digits. And has anybody gotten that answer yet?
Yeah,
52. All right.
Well, that's it.
Do you always have to put the units?
No, I'm just pointing that out because I want you all to realize that when you are finding area, it is square units. But no, I'm not going to require you to do that. All right. As always, let me get you started. Number 1 and number 2 are just straightforward, perimeter and area. Number 3, 4, and 5. You're going to have to use what you know about triangles to find the length and the width before you can solve perimeter and area. So, what kind of triangle has been created on number 3? The 30, 60, 90. So make sure you're using those ratios. Can we determine on number 4 if what those angles are? So what am I going to have to use there? Pythagorean theorem. And then on number 5, the 45, 45, 90. So just be aware of that. And then number 6 and 7 are the ones that are on the assignment that we added to the notes. You're given a perimeter, find the area. So first you have to find the side length, then you find the area. Here, finding area, given area, find the perimeter. So again, find the side length so that you can find the perimeter. I would suggest, suggest a picture on number 8. You do not have to do number 9 unless you choose to. I will not be giving you any questions like that on your test, but if you want to attempt it, you may. And then number 10 is just a composite figure. So carefully determine the side lengths that are not given. And just so you're aware, there are 2 side lengths not given. So make sure and that is when the error normally occurs, is when all the side lengths aren't given. Students tend to forget to find the one that's missing. So make sure you find that missing side length. All right, you just do it at the end of the period, so make sure you're working.
Maybe switch